is in. Hi, Jumila. Welcome back. Jumila, nice job on the midterm. Morning, then. Hi, Nidal. Good morning. Happy Friday. Irvin, welcome back. Awesome job on your midterm, Irvin. Welcome back. Tintin, good morning. Welcome back. Good morning, John. Happy Friday. Welcome to best class of the day. What's up, Santino? Welcome back. Hey, Bellman. Good morning. Welcome back. Happy Friday. Hey, Faith. Good morning. Good morning, Michael. Hey, Michael. Welcome back. Hey, Joe. Good morning. Emma. Welcome back. Hope you're doing well. Hey, Kai. Good morning. Welcome back. Happy Friday, Kim. Joey G, welcome back. Hey, Nadina. Hi, Nadina, welcome back. Hey, Asim. Morning. Happy Friday. Hey, Rye. Morning. Wendy. Welcome back. Hope you're doing well. Hey, Tristan, welcome back. I think the midterms you should be able to see on the Buzz. From what I understand, I think students saw your grade on Buzz. You should be able to see them. Thanks, Asim. Hey, Frank. Good morning. Threw it up there, by the way, for you. Hey, Phil. Good morning. Oh, hey, Jordan. You are here. Missed you. Welcome back, Jordan. You're welcome to do me live. Nice job. Wait, one more minute. I know it's perfect ending, but another minute for more people to log in. Hey, Leonardo, welcome back. Hey, Micaiah.
Hi, Mr. Brown.
Morning. Happy
Morning.
Friday. Hey, Alex. Good morning. Welcome back. Oops. All right, good morning. Welcome back. Happy Friday. Hope you guys are doing well and staying warm out there. It's freezing out there. Go outside today, bundle up. Really cold wind chills, below zero for majority of the day today as well. So just be prepared. Not a bad idea to go for a walk still, but just dress appropriately. You guys keep staying inside every day, all day, every day, stuck on screen time all day, you're still going to go crazy. So find like a little routine. Maybe it's after school. Go for like a 10-minute stroll around the block. Do something. Just get yourself out a little bit. Get some sunlight. Find a little routine. Get a little active. Maybe a run, a little jog. All right. So I'm looking for Alan. I don't think he's here right now. He's got some internet problems. I think that's it for today. All right, let's do a couple things. Check out the COVID report. Some more good news, I think, here for the COVID report. If you remember the day-to-day case numbers or total active cases, yesterday were definitely higher than this. I can't recall exactly yesterday was. Remember any cases? It's maybe 6,700. I think it was upper 6,000 for the cases, but today we're down in 4,000 active cases, 4,981 active cases in the county. So that's a good thing. It's also good that some people that had COVID is now resolved. Almost 10,000 cases of resolved cases. So hopefully this number of total active cases continues to decrease. Hopefully the resolve increases. Hopefully we'll be down to nothing before you know it. Total deaths in Oneida County are 331 cases of people passing away from COVID. There's 138 people that are in the hospital for COVID. 26 people need a lot of attention, ICU care. Let's check out the daily report for coronavirus cases. Coronavirus. Where did it even come from? So way back in the day, they said that came from China and from a person eating a bat. I don't think it really matters where it came from anymore right now. I guess it does. So it wasn't, hopefully it wasn't man-made virus. Maybe they'll tell us eventually at the end of this. I'm sure it'll come out eventually. Maybe it is from a bat. Hey, Alan. Welcome. All right, so there's the curve. You check it on out. You can see where we were the last few days. Looks like we're descending. Looks like that curve. I'm liking this. I'm still liking this. You see this. You're checking out the averages. Kind of. A little high over there. You're checking out the averages, my line here. And looks like maybe that's a midpoint. Make the sine curve. What goes up must come down. You're in the middle of that. So that might be the middle. I hope it's the middle of the second peak. Hopefully keep working our way in that direction. That's a good sign. All right, so let's check out the number of cases that we had for the previous day. So last couple days we were below 100. The last data that we have was 103, so not too bad. If we could continue at this level or lower, that would be amazing. So I'm going to keep saying, as this continues to decrease, I think schools are going to start to open up more and more and more. So our school is obviously the biggest one in the area, so that might be like, we might be like the last one to roll out the plan. There is still nothing being said right now for a timeline for Proctor. From what I understand, I haven't been related anything yet for when we'll be rolled back. But if these cases continue to decrease the way they are, I see it happening. I hope it does. So 4 days, basically 4 days below 100. We're heading in the right direction. All right, there's a COVID report for today, but it's still definitely out there. There's still 5,000 cases in Oneida County. You go to Walmart, there's still cases at Walmart. Think about 5,000 cases. Think about what we did for 8 cases. Now there's 5,000 cases still out there. It's still in the community. A couple weeks ago, Rome Walmart closed down for sanitation and cleaning. This week, Herkimer Walmart, Herkimer, New York, not Herkimer Road, Herkimer Walmart is closed for 3 days for sanitation, cleaning, all that stuff as well. So I don't know. North Utica Walmart, New Hartford Walmart, I'm sure the virus is in there. Just protect yourselves. All right, let's check out what's going on for chem class today. Awesome class, best class of the day. Here we go. If your dreams don't scare you, then they're too small. Richard Branson. Set some goals, make some bigger dreams, accomplish those dreams as well. The daily agenda for Friday, January 29th, 2021. It's a day one. This doesn't relate to anybody in here. Everybody in here took the midterm. We talked about that yesterday. Your agenda for today is going to be unit number 6. It's properties of solutions. We're starting topic number 2, which is solubility. So solubility, we're going through the warm-up first today. We'll watch a couple, or yeah, 2 flicks probably. Watch 2 flicks on one on water, one on how solids dissolve in water, and then we'll get to the notes, which is topic 2, which is very brief notes for today, but we'll go through several examples between soluble and insoluble. The attachments are below. You could check those out. If you missed something in class, I do record the videos, so you can always see those on the stream, the recorded classes on the stream. Please look up the warm-up on the page. It says warm-up U6, Unit 6, Topic 1, Solutions. We'll start off with this since it's so cold out. We'll warm up with some mixtures. So there's 10 questions on mixtures. These come from maybe Unit 2 or maybe even from this flow chart or maybe from our notes from yesterday in class. They're pretty basic questions. These are Regents questions. Please try these out. I will give you 10 minutes to work on these right now. 12 o'clock, we will review those questions. Please try them out. Okay, hopefully I had time to go through those 10 questions on solutions. I'm going to start off with question number 7 since I was working on this artwork for a while. Do want to talk about it. Sometimes there's tricky questions where it makes you really think about what's going on here, what's the process of what's going on. So at those situations, I would suggest actually making like a little diagram, little example, draw something to really think about the process of what's happening. And that's what I would suggest for doing for question number 7 because it's a little wordy at times, and maybe you need a diagram or drawing to help out that process. Doesn't have to look like mine. Probably looks better if you worked on this, which is fine. So here we go. When sample X is passed through a filter paper. So we start off with this question talking about sample X. Sounds like it's a solution. It's in an Erlenmeyer, that's an Erlenmeyer flask. It was stirred maybe by swirling, had a little swirling going on here. Or a stirring rod could use to break it up as well. But anyways, we have X, yeah, is going to be passed through a filter paper. So we're starting off, we're putting the solution inside of a funnel. Inside of a funnel is going to have some filter paper, like a coffee filter that would be inside there. Once you dump it on in, it says there's a white residue Y that remains. So you dump solution X into the funnel, it passes through, some particles pass through, but there's some residue up there as well. So as this liquid passes on through, it goes through the funnel, drips on the bottom. Now this is solution Z. So next up, it says, all right, on the paper in a clear liquid, Z passes through. So Z passed on through. And then it said when liquid Z is vaporized. So we took the solution that was here, that's inside this beaker. We took that and then we put it into an evaporating dish. And with the evaporating dish, we slowly added this to the evaporating dish. Why? Because you don't want this to be like overfill, because sometimes we want to figure out like the masses of what the crystals are created. But anyways, you put this into the evaporating dish slowly. You heated it slowly to avoid like bubbling or any residue bit that would pop off onto the lab bench. As you heated it up, you evaporated. You saw some evaporation going on there. And there's a white residue remaining. So there's evaporation, and then you have some residue inside the evaporating dish, or it could be a crucible. Sample X is best classified, sample X, this thing in the beginning, is best classified as what? Please put your answer in the chat for number 7. Thank you. Cool. All right, so a lot of C's, a lot of D's for answers for this one. So in this situation, so a lot of people said homogeneous, a lot of people said heterogeneous. So we're on the fence of what the best answer is. In this drawing, this question, I guess we didn't need anything else but steps 1 and 2. Steps 1 and 2 would really help us out here. So as you poured it in, there was white residue on the filter paper. So right here we have white residue formed. When you filter it on through, since there's some solid particles or white residue, it's got to be solid probably. It doesn't really say solid. But since you have that residue remaining on top, there's going to be chunks of white particles inside there. So it didn't say specifically there's a heterogeneous mixture from the get-go. It didn't say specifically in solution X there's solid particles. But once you poured it on into the funnel, you have some white residue remaining. Since there's white residue, this best answer would be a heterogeneous mixture. So heterogeneous mixture because you have white residue collected on top. If this was homogeneous, then all the particles would go right through. So all the particles go right through if this was homogeneous. This stuff right here wouldn't exist. Homogeneous would be all go through. Heterogeneous, you have a separation, physical separation of solid particles and liquid particles. So that solution, heterogeneous mixture. Hope you enjoyed art class for today. Digital art class. All right, let's go back to the top. Question number 1, solutions. Which of the following represents a mixture? Question number 1, please put in the chat. Which one represents a mixture? Yeah, so everybody put A so far. A lot of A's. Mixture is going to be AQ. AQ means mixed with water, H2O. So AQ means it's a mixture with water. NaCl, sodium chloride, is a solid. NH3 is a compound as a gas. NH3 is a compound as a liquid. Number 1 best answer is going to be choice A. 1 is A. Next up, number 2. Which sample represents a homogeneous mixture? Please put the answer in the chat. Yes, Joey. Alex looks good. Thanks, Faith. Thanks, Asim. Nadine looks good. Thank you. Thanks, Zin. Yeah, so homogeneous mixture. Homogeneous means, homo means the same. Genius, homogeneous mixture, same type of mixture, same consistency mixture, however you want to think about it. It's the same throughout. Which one's a mixture? It's choice B. Aqueous is actually referring to a homogeneous mixture. So again, mixture, that's a homogeneous mixture. Again, they could ask is choice A for number 1. Number 2, the best answer is going to be B. Number 3, which material is a mixture? Please record in the chat. How come, Faith? How come it's that? You're right. No, yep, Faith, you're right. How come? Nope, Faith, I'm sorry. I'm sorry, Faith. Where's someone else for this one? How come, Alex? You're right, Alex. Throw in the chat or on mute. Why is that the best answer? Yeah, it's combination of gases. So air is the best answer. Which one's a mixture? Alex said choice B. I think a lot of you picked choice B as well. Air is a combination of different maybe molecules or different compounds. In air, you have O2, which is oxygen gas. Plus, you also have carbon dioxide, CO2. Plus, you have water vapors, particles of water. Plus, you have several other things that are in there as well. It's a combination of several compounds, a combination of several molecules. If you look at choice A, water is just H2O. It's not a mixture. That is a compound. If you look at choice C, methane, you probably don't know what that is yet, but methane is CH4. You will by the end of the year. That is a compound. Choice D, Mg, we know is an element. And obviously choice A is choice B is a combination of several, which is a mixture. 3, the best answer is choice B. Choice B for 3. Number 4, which is a characteristic of all mixtures? Please throw in the chat. Which is a characteristic of all mixtures? Mixtures. A mixture is a physical blend of 2 or more components. All right, that doesn't really help us too much. Compound is going to be a definition for fixed ratios. Substance that contains 2 or more elements chemically combined in fixed ratios or definite proportions. So it's definitely not choice C. That's a compound. Best answer is going to be choice D. A lot of you guys already picked that. Mixture, the composition could vary. Maybe like your lemonade sweet, maybe like a little sour. You could vary the amount of sugar you put in Kool-Aid. D's the best answer for that. Number 5, when a sodium chloride is dissolved in water, the resulting solution is, please throw in the chat. All right, there's no such thing as homogeneous or heterogeneous compounds. So homogeneous or heterogeneous mixtures. I never said homogeneous or heterogeneous compounds. So right there, you get rid of choice A and choice B. Key word here is dissolved in water. Since you took NaCl, you dissolved in water. That's a key indicator. All right, you take the NaCl, and you dissolve it in the water. So take those little particles of table salt, put them on in there. They're going to dissociate. They're going to dissolve once you put them into the water. So those little particles that are there, they're going to dissolve. It says dissolves in water. So you can't see those particles anymore. After you throw them in, you stir them on up, you shake them on up like Taylor Swift, and then they dissolve. Best answer here is going to be the same throughout. It's homogeneous mixture. Homogeneous mixture, choice D for number 5. 5 is D. Number 6 is similar. Sugar dissolves in water. The resulting solution is, throw in the chat, please. Yeah, Micaiah said A. I can waste anybody's time. Sugar dissolves in water. If you make coffee, the sugar is going to dissolve in water. You make whatever, tea, the sugar dissolves in water. Since it dissolves, it is going to be a homogeneous mixture. Thanks, Micaiah. Number 7 we went through. Number 8 is a tough one. In an aqueous or aqueous solution of potassium chloride, the solute is, let's throw in the chat. Solute is what? That's Faith. That's Jumila. So I definitely think if you're interacting in class, you're trying these questions out as we go throughout, I think it'll make your class or your experience of this virtual world of learning a lot better. If you're just sitting back in the nosebleed section of this awesome chemistry game, then you're probably not gonna get much out of it. Yeah, so solute you're looking for, maybe you had to refer back to your notes. Solute is what you add to the solution. It's a smaller quantity. It's a substance that is being dissolved. The solvent, didn't ask about it, but the solvent dissolves the solute. Water is the most common solvent. So anyways, in this question, it's talking about KCl. So you have potassium chloride, KCl. You could figure that out. You could figure out the ratio. You could figure out the charges, all that stuff. The solute, oh, we also have aqueous solution. So we know it's going to be KClAQ. So it should look like that. And hopefully you know you have an ionic compound dissolved in water. So it's like table salt dissolved in water. So two things you have in this situation. You're going to have KCl, plus you're going to have water, H2O. Let's know which one's the solute. So you're mixing those up. The solute is going to be the KCl. KCl is going to be the smaller quantity. Like NaCl, if you mix them together, KCl is going to be the one dissolving, the thing dissolving. So choice C is the best answer. Solvent would have been H2O. Those two are just there to throw you off. So choice C is the best answer for that. Solute, what you add, the smaller quantity, what's dissolving, KCl. Number 9 wants to know which statement is an identifying characteristic of a mixture. Mixtures can be 9, thank you. We're 4 for 4, 5 for 5. Thanks, Zen. Zen says it's B. Best answer is B then. Can be separated by physical means. So yeah, if you have table salt and water, you could separate them by evaporation. If you have a heterogeneous mixture, if you have a sample of oil and water, you could separate those out by obviously pouring out the oil on top, or you could just squeegee it or just suction it up with a pipette to separate them as well. You can use different matters. You can use distillation. You can heat them up. You could filter them up. Mixtures can be separated by physical means. Choice B. Thanks. Then the last one. Which diagram represents the mixture? Yeah. Diagram represents a mixture. I think you've seen something similar to this before. Faith's my only answer here. She said choice B. That's the best answer. Thanks, Faith, for being confident. What does A represent, anybody? A represents a compound. Physical blend of two or more elements. So that could be like H or H and Cl, or maybe NaCl in a gas phase. Choice B has two different elements mixed together. That's a mixture. Choice C is what? It's a gas phase of an element. So it's an element in the gas phase. So it's element Z in the gas phase. How about D? What is that one? Yeah, D. Good job. Nice job. Not many people got that one. From my other classes. Maybe from this class, but not my other classes. That's a diatomic. Sorry, I didn't give enough time, everybody. Diatomic molecule. Two of the same things bonding together. What's an example of a diatomic molecule? What are the diatomic molecules? Which elements form diatomic molecules? What's an example? Okay. A little refresher on diatomic molecules again. Yeah, H2 is an example. If I pull up the reference table, diatomic molecules, I don't know how to give it this side panel over here. It just randomly popped up today. I'm like, what the heck? Diatomic molecules could be formed between H2, somebody said, thank you. So H2 could be a diatomic molecule. It means it bonds with itself. Remember we did N2 bonds with itself. That's a triple bond. O2 bonds with itself is a double bond. F2 could bond with itself as a single covalent bond. Other ones that could be diatomic molecules, we said no other fools. We said chlorine, bromine as well. So those are the ones that can form a diatomic molecule, and actually iodine. 7-Up, remember that? 7-Up. 7-Up, we said. So 7-Up is the middle form to represent it. There's your 7. And then the up is over there. 7-Up. All right. That assignment you could submit if you want to. You don't have to submit it. I'm not grading them. Again, going into the third quarter, the only thing I'm grading right now are exit passes, guided notes, benchmarks. So exit passes, guided notes, benchmarks. Again, I'd like to go to warm-ups to do those warm-ups for grading sometimes, but I haven't reached that point yet to feel comfortable with that for you guys. I like the warm-up to like slowly get into class and review. And then the exit pass, I kind of want you guys to do that on your own. So I like that routine for where we're at. All right, please open up your guided notes. But before we do that, I'm going to play the first video, which is on water, real water. Easy. All right, the first video is on how polarity makes water behave strangely.
How come some insects are able to walk on the surface of a pond, but you quickly sink to the bottom when you try to walk on water? And why do lakes freeze from the top down in winter? In a word, the answer to all of these questions is polarity. Water is a simple molecule made up of one oxygen atom and two hydrogen atoms, but it is essential to life. In fact, water makes up approximately 60% of the adult human being's body weight. The polarity within those water molecules gives this common substance the properties that make it unique and life-sustaining. Polarity refers to the unequal sharing of electrons within a molecule. For water, between the oxygen atom and two hydrogen atoms within a single water molecule is like a tug of war between a big, strong football player and a cute little toddler. Oxygen is a larger atom with more protons in its nucleus than hydrogen. These positive charges are like a person's physical strength. They are able to attract the negatively charged electrons in the bond, just like a strong individual is able to overpower a weaker individual in a tug of war. So, oxygen is able to attract more than its fair share of electrons. Because hydrogen is smaller and has less strength, or fewer protons, it loses the tug of war and attracts fewer than its fair share of electrons. So the oxygen in water behaves as though it's negative, and the hydrogens behave as though they're positive. The bonds within a single water molecule are called polar covalent bonds. Covalent means that the electrons are shared, but as we just learned, polar means that these electrons are not shared equally. In water, the oxygen acts negative, and the hydrogens act positive. Since negative and positive attract, that oxygen is attracted to the hydrogen atoms in neighboring water molecules. A special type of bond forms between water molecules known as a hydrogen bond. Hydrogen bonds don't just happen in water either. They can form between a water molecule and different substances that are polar or ionic. Water's ability to stick to itself is called cohesion, while water's ability to stick to other substances is called adhesion. Now, think back to the initial questions. First, why are some insects able to walk on water? Surface tension due to hydrogen bonding creates a thin film on the surface of water that gives enough resistance for super light insects to walk on. You can't walk on it because the hydrogen bonds aren't strong enough to hold you up. Why does ice float on top of liquid water? For most other substances, the solid state is more dense than the liquid state, but that is not the case for water. Hydrogen bonds keep water molecules farther apart in frozen water than in liquid water. The farther apart the molecules are, the less dense that solid is. So ice is about 9% less dense than water, which means it floats on the top. That's why lakes freeze from the top down and aquatic life is able to survive through a cold winter every year. It is the polarity of the water molecule and the resulting hydrogen bonding that account for water's unique properties. So, the reason that water is so special, from inside your cells to the world's oceans, is simply because it is a polar molecule.
Okay, there's a little bit more insight on water. I will play one more video now on why do solids dissolve in water.
Everyone is familiar with table salt, also known as sodium chloride or NaCl. This compound forms because chlorine molecules steal an electron away from sodium molecules, forming sodium cations, which have a positive charge, and chloride anions, which have a negative charge. Now, these two oppositely charged ions attract each other. This attraction brings together tons of sodium and chloride ions, forming the solid structure that we know as table salt. And this process happens with many ionic compounds. Now people ask, but what makes salt dissolve when you put it in water? Well, water is an extremely interesting molecule, mainly because water is a bent molecule, which leads to its polarity. We won't go into why water is bent in this lesson, but if it were straight, it would not have polarity. Oxygen is what we call an electronegative atom. It's way more electronegative than hydrogen, which just means that it wants to grab electrons more than hydrogen. Therefore, electrons are then pulled toward oxygen, and because electrons are negative, the molecule has an uneven distribution of charge, with the negative charge being towards the oxygen. The chemists call this type of molecule a polar molecule, which just means that the negative and positive charges are unevenly distributed throughout the molecule. Now, like I said before, water is bent, so because it's bent, it places the hydrogens on one end of the molecule and the oxygen kind of on the other end of the molecule. And so the oxygen end is negative and the hydrogen end is positive. And when this water is added to sodium chloride, the positive sodium ions and the negative chloride ions are more attracted to these partially charged ends of the water molecule than they actually are themselves. So therefore, uh, the positive sodium ions will break away and attach to the negative oxygen of the water molecule, and the negative chloride ions will break away and attach to the positive hydrogen ends of the water molecule. And these water molecules then just surround these ions. And now we have a liquid solution because when atoms aren't tightly packed together, forming that structure, they won't be a solid, they'll be in liquid form. So this whole concept of solids dissolving in water simply comes down to the fact that water is polar. It's polar because it's bent and because oxygen wants to steal electrons away from hydrogen. And therefore you have a molecule, a water molecule, that has one side that's more negative and one side that's more positive. And this will come in and essentially break apart the sodium and chloride ions from attaching together.
All right, so there's more information about water. I think we are pretty clear with what water is and a lot of information about it. Please open up your guided notes. Moving on forward. Guided notes. There's going to be a really small section of notes for today. It's going to be like 5 minutes. And then the rest of the class, we're going through some examples. All right. So please open up your guided notes. Where we left off, we talked about topic number 1. There's going to be a lot of S terms, solutions. We talked about solutions. We talked about solute, solvent. Today we're talking about soluble and insoluble for solutions. So there's going to be a lot of S terms in this unit. It is not a bad idea to make a little flashcard to differentiate between all the S terms within this unit. We talked about alloys, solute, solvent. We talked about water. We drew how like water dissolves salt, NaCl. We talked about properties of solutions as well. Next up, solubility factors. So literally, this is all we're going to copy down for notes today. And then we're going to analyze this chart. So again, I don't care if you actually highlight this and put it in a different color. I highlight it just so you guys can see what I'm inserting into my notes. So solubility factors, solubility. Solubility is the amount of solute. So we should know what a solute is. The amount of solute that will dissolve in a certain amount of solvent at a certain temperature. So amount of solute that will dissolve a certain amount of solvent at a certain temp. So if you guys ever made iced coffee before or regular coffee, if you ever added sugar in there, you know what I'm talking about. So if you work at Dunkin', if you work at any place that makes iced coffee or something like that, a lot of times they have students that work at Dunkin' Donuts, so that's why I always say it. When you make iced coffee versus hot coffee, if you add sugar to both those solutions, you probably know which one dissolves quicker. If not, if you make coffee and you throw some sugar in there, the hot coffee is going to dissolve the sugar pretty quickly because it's so hot. The higher the temp, the easier or the quicker the reactions are going to occur. If you make iced coffee, if you're with somebody at Dunkin', they're making iced coffee for you, sitting in the car, they're probably making the iced coffee, they're throwing the ice in, they're throwing the sugar in, they're throwing the coffee in, and then they're like constantly always shaking that coffee just to make sure the sugar dissolves. So they're going to shake the iced coffee a lot more than the hot coffee makes, just like a few swirls done. Temperature determines how quickly the particles will dissolve. Next up, materials with high solubility are said to be soluble. So high solubility is something that will dissolve at a quick rate. Soluble, high solubility, dissolves quickly. Materials with low solubility are said to be insoluble. So they're not going to dissolve very quickly. So low solubility are things that are not going to dissolve very quickly. And they're called insoluble. Low solubility, insoluble, not going to dissolve very quickly. High solubility, it will dissolve quickly. It's called soluble. That's it, folks, for notes for today. Moving on forward, we're going to go through this chart below. You may want a reference table, or you may want to follow along with this chart. Once you're done with the notes, that's it for the notes. You don't need to open this anymore. Instead, we're going to open up the examples. It's the last thing assigned on our stream, our homepage. All right. So I'm going to open up the reference table, and I'll open up the examples on the stream. So again, classwork, examples, this is what I'm opening up. I think you guys probably have your notes done. Examples, it says table F, soluble or insoluble. And I also need a reference table opened as well. So on the reference table, I'm going to analyze page 2 of the reference table. It's all the way on the bottom. Table F. So how does this chart work out? So table F, we talked about polyatomic ions. Now we're going to highlight table F, page 2. Solubility guidelines for aqueous solutions. So all these things are mixed with water. So they're mixed with water. Aqueous solutions mixed with water. When you mix these things with water, they're going to be one of two things. They're either going to be soluble, which means they're going to mix or dissolve really easily, or they're going to be insoluble, which means they're not going to dissolve very easily, or even not at all. So soluble means they're going to dissolve. Insoluble means they're not going to dissolve as easily or at all. All right, so first off, let's focus on the soluble side of the curve. With soluble, we have several different situations that are soluble. If you have a group 1 ion mixed with anything at all, group 1 ion mixed with anything in water, then it's going to remain soluble. Ammonia, if you mix it with anything, it's going to stay soluble. Nitrate mixed with anything, it's soluble. Acetate, which is C2H3O2 or CH3COO, it's the same amount of moles of each of the atoms, same thing. They're going to remain soluble. Hydrogen carbonate, soluble. Chlorate, soluble. Here's the first one we do want to check out. If you have a halides, halides come from halogens, halides, halogens. These are located in group 17. Cl, Br, or I, if you have one of those halides, if it's mixed with Ag, Pb, or Hg, if it's mixed with any one of those three ions, it's going to change from soluble to, so if it's mixed with one of these three, it's going to change, because there's an exception, it changes from soluble to insoluble. Whenever an exception occurs, it changes the dynamics to the other side. So if these halides bond with anything else besides those three ions, then they're going to stay soluble. When an exception occurs, it goes to the other side of the chart. So it changes from soluble to insoluble, or vice versa, whatever the exception is. If an exception occurs, it goes to the other side. Sulfates. Check out sulfates. Sulfates, you have SO4. So SO4 with anything besides Ag, Ca, Sr, Ba, or Pb, if the exception occurs, it goes to the other side. So if SO4 bonds with Ag, Ca, Sr, Ba, Pb, if SO4 bonds with those, it's going to be insoluble. If the sulfate bonds with anything else besides, or they five ions, then they're going to remain soluble. So yeah, this is going to be tricky at first, but we're going to analyze several examples so we can understand it together. Next up, the second part of the chart, you have insoluble. So they're going to stay on, all these compounds are going to stay on this side unless there's an exception that occurs for the ions. Similar to the last idea, carbonate, when it bonds with group 1 ions or NH4, when that exception occurs, it goes to the other side, to soluble. But when carbonate bonds with anything else, it stays on this side of the curve, the chart. Chromate, when it bonds with group 1, Ca, Mg, or ammonia, it goes to the other side. If it bonds with anything else, it stays here. Let's try some examples. Let's just go right to it. All right, let's try some examples. Jamila, I know you messed me, but let's just try some things here. Examples, let's pop that open. I think we'll get it with practice. Soluble or insoluble? Oh, look at this garbage. All right, question number 1. I'll do a first few questions together. I think we'll start to see the routine of these questions. Question number 1, according to table F, okay, which of these salts is least soluble in water? Okay, so we have to use table F. We know that. It's telling us in the question, use table F. And it wants to know which of these salts is least soluble in water. So I guess this could be tricky. It says least soluble. Least soluble is going to be not soluble. If something's not soluble, it's going to be referring to insoluble. So you're looking for something that's going to be insoluble. Insoluble. Least soluble is not going to be soluble. It's going to be insoluble. So you have to know it's going to be insoluble. All right, so the first question we have responses Li or Cl. So letter A, find either Li or Cl. Li or Cl. Li or Cl. So here we go. Find lithium or chlorine. Maybe, oh, there's lithium. Right from the get-go. It's in group 1. You know, lithium's in group 1. If not, you can look at the reference table for reference for that. When lithium bonds with anything, there's no exception, so I don't have to worry about it. When lithium bonds with anything, it is going to remain soluble. So lithium bonds with anything, there's no exceptions, it stays on this side of the chart. So this is going to be soluble. There's no exceptions. Maybe you wanted to find Cl instead. Maybe you overlooked lithium. You checked out Cl. There's Cl. It's a halide. Let's see if Na or Li is an exception. No, no, no. Oh, when Cl and Li bond, it still stays soluble. So there's a couple different ways you could find the answer for these. The first one's still going to be soluble. Let's check out the next element or compound, Rb and Cl. Let's find Rb or Cl. Cl, there's Cl. When Cl bonds with Rb, let's see if Rb is an exception. No, it's not. So Cl bonds with Rb and Cl, it's going to remain soluble. So that is going to be a soluble compound. It's going to dissolve pretty quickly. Rb is also in group 1, so you could have found that here as well. Next up, let's try another one. So those two are soluble. We're not there yet. Next we have Fe and Cl. So find either Fe or find Cl. All right, looking for Fe or Cl. Scrolling. Oh, there's Cl again. Let's see if Fe is an exception. No, no, no. So now Fe and Cl bond. Fe is not an exception. Therefore, when these two get together, it's going to stay soluble. So that's soluble too. And let's check the last one. Hopefully we'll get lucky here. Last one is PB and CL. All right, so we'll find PB or CL. There's my CL again. We've analyzed that for each of these. And PB, uh-oh. So when combined with PB is an exception. When combined with PB, so when PB and CL bond, there's an exception. It changes to insoluble. So PB and CL, that is going to be the insoluble compound here. That's not going to dissolve very easily with water. Number one, best answer is D. Yes, Joe, thank you. I just saw that. So one best answer is D. Next up, let's try another one. This is a part 2 question on the Regents. I don't know whether or not we're going to have Regents or not, but if we do, the typical setup of the Regents is 50 multiple choice questions and 35 short answer questions. No, there's no lab practical for this exam. Earth Science, there should have been one, but this one, there's no lab practical, hands-on experiments that you have to perform. There's 35 short answer responses. This would be one short answer response type of question on the Regents. Based on reference table F, describe the solubility of magnesium hydroxide in water. Magnesium hydroxide. Okay. Maybe you want to start off by drawing the formula or representing the formula for magnesium hydroxide. Magnesium is Mg. Magnesium's in group number 2, has a charge of +2. Hydroxide is, maybe you know it. Maybe you don't know it. You will know it by the end of the year. We'll do a unit on bases, acid and bases. This is a base. Hydroxide is a polyatomic ion and is OH negative. Sounds like a blood type. OH negative is hydroxide. You could do the formula if you want to solve for the formula. Crisscross Joseph A. But obviously, we don't need all that. All we care about is which elements are bonding. Mg, OH. Okay. So let's find it on the table F. It wants to know the solubility. So when it says solubility, it wants to know, is it soluble or is it insoluble? Is it soluble or insoluble? Knowing that alone, you have a 50-50 shot at getting this question correct. Look at those odds. Find Mg or find OH. Again, Mg is in group number 2, so it's not this one. Find Mg or OH. No, nothing in the first chart. Oh, OH. There it is. There's OH. And Mg is the other thing we're looking for. It says when combined with group 1. No, it's not in group 1. It's in group 2. Ca, Ba, Sr, or NH4. That's an exception. Mg does not fall into the exceptions. Therefore, Mg and OH are going to remain insoluble. So Mg and OH are going to be insoluble. That would be the response for question number 2. So it's insoluble for question number 2. Anybody have any questions so far on this? I know some of you guys already get it, but I know there's several people that are still stuck on this stuff. What are you talking about the exceptions? What do you even mean? What are you even talking about? Mr. Brown, it's Friday, I'm freezing. I just want to get out of here, I know. We're getting closer. All right, let's try this one out. I'll give you guys 2 minutes to try this out on your own, and I'll highlight some stuff here as well. So try it out. See, I'll get a gauge of how you guys are doing with this stuff right now as well. Give me 2 minutes. Okay, please put your answer in the chat once you derive an answer. I'm going to continue just to sit here quietly and keep working. All right, hopefully you can follow that little flow or understand what we did in class so far today. Yeah, so a lot of you guys have the correct answer. I color coded this so you guys could kind of read this. Choice C, if we check out CaPO4, CaPO4, there's PO4. Ca is in group number 2. It's not in group number 1, so it's not going to be a part of the exceptions. So when Ca and PO4 get together, they're going to be insoluble. Everything else has an exception, like CO3, K and CO3. They're changing to the other side. Those would be soluble. So everything else is soluble. All right, there's the first 3 examples. Let's do just one more example. So number 3, the best answer is going to be choice C. 3 best answers, C. Does anybody have any questions before I go further how we did that? I know this is kind of tricky, analyzing this chart. All right, let's just do one more example. Question number 4. Which ion, when combined with chloride ion, forms insoluble substance in water? So please try out number 4. I'll give you a minute, 30 seconds. A little easier question. All right, please throw your answer in the chat for the last one. Number 4. Thanks for your participation. Appreciate it. Several C's and one more other answer there. Which ion, when combined with chloride ions, forms insoluble substance with water? So I color coded this again. You can see my little connections. Fe when it bonds with Cl. So I found Cl. There's my Cl. Fe is not in my exception. So Fe is not over here. So when Fe bonds with that, it's going to stay soluble. Next one up, we have Mg and Cl. So Mg and Cl. There's my Cl. Mg is not the exception. There's not an exception for Mg. That remains soluble. Next up is choice C, and it says Pb in Cl. So Cl and looking for Pb. Oh, there's Pb. It's an exception. When Pb and Cl bond together, it's an exception. It's not going to stay soluble. It's going over to the other side. Going over to the dark side. It's going to be insoluble. So that one looks like it's a solid answer. A lot of you guys picked that. Let's just check out the last one for reference. Zn and Cl. Zn's not an exception. Therefore, it's going to remain soluble. All right, guys, next time we're going to do 5 through the rest of the questions. We'll finish those up next time. At this point in the game, you're free to leave. There's no homework for this week. We'll start fresh with exit passes due next week. If you want to see your quarter 2 grade, just hang out, join your own breakout group. I'll go to each person individually, and we'll go through that as well. If you're willing to wait till report card time or another time, then I'll see you later. If not, if you want to hang out during the breakout group, I'll go through you guys slowly. It's going to take some time for me to download the little document, but I will do that for you as well. Have a good weekend, guys. We'll see you later. Stay safe. Be smart. Protect yourself. Protect your loved ones. See ya.
Bye, Mr. Brown.
See you later. Have a good one. Stay warm. Anybody
Have
that
a great
wants?
day, Mr. Brown.
See you, Frank. Have a good one. Thank you. If you want to hang out, join a breakout group. I'll show you your grades. Irvin, my first man up. Irvin. Let's check it out. Makai, do you want to see your grade or no?